So, welcome to today's webinar. As you can see, this series is slowly coming to an end. If you are interested in one of the topics that we already covered before, all the recordings are available on our YouTube channels. Just head over to YouTube, type APIDA into the search bar, and you should find all of them. So, today's topic is all about security. It's about what you have to consider when it comes to security while you are implementing APIOps. Because there are some special challenges around APIOps that need to be solved or that need to be addressed in order to really have secure APIs. My name is Markus Müller. I'm co-founder and CTO of APIDA, and I will run you through that webinar today. So, to get started, first of all, a short recap. Why is API security so important? Well, the number of APIs grows exponentially each year. So we have customers that have hundreds of APIs published to the internet. So it is really important to have airtight security, to have an automated security guidance and an automated security enforcement, because with such a high number of APIs, you are not able to do that all manually, to do that all with manpower. And as we will see, there are possibilities to automate security and to automate governance. This is especially important as Gartner predicts that this year APIs will be the main attack vector in the internet. So attackers are not attacking the web pages anymore. They are trying to attack the underlying APIs, because those often have direct access to the upstream systems, which means that if you are successful in breaching one of those APIs, if you are successful in having privilege escalation, you gain access to a whole lot of systems and possibly to a whole lot of more possibilities than by attacking the website. And as more and more businesses rely on APIs, the API layer going down means that you lose business, you lose money, and a lot of it. So it was always important to have secure APIs, but it's getting even more important day for day, right? And that is why we are talking about this today. Another short recap. What is APIOps all about? Well, APIOps is about bringing people, processes, and tools together to achieve better business outcomes. So usually you want to increase speed, you want to raise your quality of your APIs, you want to reduce the risk that you have. And to do so, APIOps uses practices, principles, and methods from DevOps and GitOps, specifically tailored to the API lifecycle. So one thing that we will be looking at during the next 45 minutes, or maybe less, let's see, is the feedback cycle. So whenever you have a change in your API, you want to build that change, you want to build that API and the API proxy that's running on some gateway. You want to test it, you want to put it into release, and then you want to monitor how is it performing? Is it behaving like you expected it to be? Are the customers happy? Do they get the outcomes out of it that they expect? And then you start that cycle again. So key here is to have that cycle as fast as possible, right? Because you want to measure the success of your change, and you don't want to measure it in like 2 weeks in time. You want to measure it as fast as possible so that you can do new changes as fast as possible. So the whole principles of DevOps basically enable or optimize for flow. So you're going to reduce constraints, you're going to reduce bottlenecks, you're going to reduce handoffs. You really try to maximize the flow throughout the organization. And to do so, you use automation. And automation in the DevOps, from the DevOps perspective, is a CI/CD pipeline. So continuous integration, continuous deployment. And they automate all the steps necessarily to do change to production, right? To go that way from change to production. And that means they greatly reduce the mean time of change, which is a metric that is tracked by a lot of companies in order to see if their organization, their development organization is up to speed. And what these pipelines enable you to do is that you can do changes on existing APIs and maybe put them in production automatically, but also to publish new APIs to the corporate API catalog. So the basic mantra in DevOps is you build it, you run it. There's no handoff to a special team that takes care of publishing that API. No, when the backend team decides it's time to release, it's time to release. Again, optimize for flow. But if everyone can push changes to an API, if everyone can publish new APIs, how do we make sure that all of these meet the requirements on security and on quality that we have, right? Because what you don't want to have is you don't want to release bad APIs. You don't want to release unsecure APIs. So what can you do there, right? So first of all, we are looking at the different security measures that there are to secure your APIs. And then we are looking at how to apply these security measures within an APIOps context. So the first security measures that you can do is on a spec level. So for those of you that are not familiar, an API specification, or spec for short, is what we call the API design. So in that spec file, everything is expressed. So you have like what endpoints are there, what endpoints can be called, how do I authenticate against these endpoints, what methods are supported, how does the payloads look like for the request, for the response. And that is expressed as a configuration file, usually YAML or JSON, that is readable by machines and that is kind of readable by humans too. So in this spec, the whole contract of the API is defined, right? As I said, we have all the responses, you have all the requests, you see what values there are. Now, what you can check there, or what you can do on a spec level to improve your security, is limit the amount of data you return. So if your consumers only expect a subset of data, only put this subset of data in the response. Don't respond the whole data set, don't respond all fields, because the consumers don't need them, and all you do is giving a potential attacker more information to plan his attacks. So be frugal with your data. Everything that is not required for people outside of the organization to know, don't put it in there. And that basically also means that if you have different kinds of consumers, one type of consumers, perhaps internal entities that need a lot of information, and external entities that don't need so much information, you maybe want to think about splitting up that API into two APIs with the different scopes. For more information on that, refer to the episode where we were talking on API as a product. And the basic idea is your API is a product, and the product has a defined use case and has a purpose. So don't try to put all of your use cases into that one API and make it a God API. Make sure that the API is built for that task you need it to handle, not for everything else. What you can also do on the spec level is you can do injection protection. So no matter if your SQL injection or that infamous log4shell vulnerability, on the spec level, on the contract, you can make sure that every parameter has the correct data type. For example, if that field only accepts number, make sure that it's in the spec, that the spec says, okay, here is only a number valid, and it has a minimum ratio or it has a minimum value of 0 and a maximum value of 100. Also for the string types, if you have a string, any set of characters, and you limit its size, that greatly limits the ability for this certain attribute to be used in attacks, in injection attacks, because those injection vectors, those attack vectors, they are usually quite large strings. So if you have, for example, German postcodes, those can only be like 5 characters. They never can be more than 5. So restrict the length of a field that has the German postcodes in it to 5 characters, not more. And the most important thing is keep the spec up to date. That spec needs to be in sync with your real API. And your real API needs to enforce all of these rules that you write down in the spec, because it's one thing to write in the spec, yeah, it's a maximum of 5 allowed, and then your API accepts 7, 8, 9, 10. So make sure that is in sync. And also, if you remove endpoints from your API, remove them from the spec. Not only, it's even more important the other way around, not just remove them from the spec. If you say, okay, nobody is supposed to use it, I remove it from the spec so nobody knows it's there, I'm safe. No, you then have to also remove it in code on the upstream side in order for people to really not be able to use it. The second level we can apply security measures to is the proxy level. Now, a proxy is basically the set of code that is generated on API gateways that is protecting your upstream API. So if you publish an API on a gateway, that gateway creates some proxy code. That proxy code is called by the consumers. It does all the necessary security checks and then forwards the request to your API. Well, at that level, for sure, you can use transport level security. So always encrypt everything that you have encrypted. You can enforce application level security. So make sure that you exactly know who is calling your API. Don't accept calls from anyone unless it really is a public API where you just don't care. Otherwise, make sure people register their applications that want to access their API and that they use API keys in order to authenticate themselves. And of course, also authenticate the user on whose behalf that call is made. So for example, you might have, let's say, the Facebook app, right? So the Facebook app authenticates itself, like, okay, I'm the Facebook mobile app, and I'm doing my requests for this user. So make sure you always authenticate both of them. Additionally, make sure that your configuration is bulletproof. So make sure your course is ready, right? So with course, you can also make sure that calls are only coming from sources you trust. So make sure you configure that correctly and don't disclose too much information. Don't tell the consuming application, for example, in the return HTTP headers, what system you are running, what version you are running. That's even better because, or even worse, because that means that an attacker can then scan the known vulnerabilities for exactly that system with that version number, and then he basically gets a blueprint for an attack against you. So make sure, again, that you give out as little information as possible. What these proxies can also do, we talked about that spec, that schema, and you can validate against that. So what gateways can do is they can analyze the incoming requests and make sure that they are according to the spec. So they can deny any request that's not valid. And the more you can filter and the gateway, the better. They can also do injection protection. So for example, you can filter or check all of these string fields, for example, for known vectors. And of course, you should apply rate limiting and throttling, which basically means that you limit the number of requests that any one consumer is able to post against your APIs, because you don't want to have a denial of service attack. You want people not to be able to brute force anything and just hammering at your API trying to find a gap. So use rate limiting, throttle them down, make repeated calls slower, unless, of course, the consuming application needs that speed. But most of the time, consuming applications don't need so many requests per second because they have to do processing themselves, right? So basically, if you see APIs get a lot of traffic in a very short time with really bursts like tens and 20, 30 requests per second, that usually is someone trying to brute force his way in. The third level of security is the process level. So always make sure that you act according to need to know. So only the systems that need to know something, only the people that need to know something in order to do their job should have that information, right? Don't put everything, post names, whatever, out of big posters for everyone to see, right? Make sure only the people that need to know actually know. As well, we're talking about pipelines here, and pipelines are defined in code. And we talk about pipelines that connect to different systems. And that means in order to connect to a system, you need to authenticate yourself. So the pipeline itself needs to authenticate against different systems, which basically means it needs the credentials, and these credentials are secrets. So really make sure that you don't have any plain text secrets or tokens in your pipelines or in your repositories in general. So this is really important. Sometimes someone is testing something and just, yeah, okay, I don't add a secret. So all of these CI/CD pipelines have vaults or other possibilities to store secrets in a secure manner and to inject them into the pipeline in a secure manner. But sometimes people are testing and, okay, I just add the configuration here. Okay, now it goes, now it works, great, bug fixed, okay, and I call it a day. And they leave their token, they leave their password in the code, in the pipeline. So you don't want to have that. You need to make sure on a process level that that doesn't happen. And of course, you want to prevent shadow or zombie. Another term is orphaned APIs, which basically means that these are APIs that you don't know that are even there, right? So somebody created them, but told no one about them. And if you have good audit procedures, you find them one day. If your audit procedures are not that good, that means that perhaps you don't know that there's an API that is exposed to the internet. And for zombie APIs, it's just, okay, who's the business owner? We don't know. Okay, who can we ask if that is configured secure? Who can we ask if we can, deprecate it, if we can turn it off? No one knows. So in doubt, most companies just have them running. So this also is a security threat that you need to tackle on the process. Now, we have now described what security measures you can do or you can enforce, but how actually to enforce them, how to check for violations within the context of APIOps. And remember, APIOps is all about automation. So someone does something and that kicks off a whole pipeline of things, and at the end it's published. So how to make sure in the step between doing the change and having it published to production that actually everything goes according to plan, goes according to your guidelines, and that is essentially people are not allowed to publish unsecure APIs. So as I said, APIOps draws from DevOps and from GitOps. So GitOps is heavily used in infrastructure management. And there you have the same problem, like someone defines change to infrastructure. Now, do you blindly trust them and carry out that change in production? Or do you have one approval step? And if you want to have such an approval step, what you can do is you can work with merge requests. Now, on some platforms, they are called pull requests, but the idea is basically the same. Developer creates changes. So there is a change set. And then he basically wants to merge that with the main code base. So he does a merge request, and that merge request needs to be approved. And until it's approved, it's not merged to the code base. The pipeline doesn't pick it up and doesn't put it into production. So someone has to do a manual review. These pull and merge requests, here is a simple example. So there is a review requested. And as long as that review isn't there, you can't merge it, right? Depending on your configuration of your pipeline. And such a merge request, it contains every change that has been made to that API for that specific feature, for that bug fix, for whatever. So it's all of the change set all the changes that you need for this change to happen. And the reviewer has the ability to check the state or the code before and after the change. So you can really see, okay, that has changed. So that was the old value, that is the new value. This code has been deleted, this has been added. And they are a living document. So what you can do is you can, review the changes, and then you can set a comment where you say, okay, I'm not sure about that. Have you tried that? Does it really work? It kind of looks wrong. Why don't we try to do it like that? And then someone can pick up on that, can, update the change, can do a new change, and everything is collected in this merge request. So you can update it, it's a living document, and after everyone is happy with the change, then you can approve it, and then the automation continues. So inside of such a manual merge request review, you could do all of the checks to enforce your security measures. So the reviewer could say, okay, is transport layer security activated? Okay. Are API keys required? Okay, that's fine. How does my spec look like? Oh, wait, there's something I don't think that is allowed by our IT security guidelines. And then he just, declines that request or, works together with the developer to solve it. However, a lot of these checks can be automated as well. So, and these automated checks can be executed by the pipeline before a merge request happens, before it is merged into the deployment, and again, before that deployment is brought over to production. And as you can see here in that screenshot, both of these techniques can be combined. So we have here some automated checks that were all green, and now there's a pending review, and somebody needs to review the changes. And the more you can of these checks that you can automate on your platform, the better. And as we will see, there's a whole lot that can be automated, and that really brings down the effort. I'm not saying you get security for free, but it brings down the effort tremendously. Some of these checks can also act as quality gates. So you now perform checks on security. So you now have to decide what happens if one of these checks fails. Now, there might be some baseline rules where you say, okay, if that fails, stop the pipeline, nothing is deployed, this has to be redone, this has to be corrected until we can proceed. There might also be some minor issues, some style issues, where you say, okay, that's not so bad, we have to work on that, but we can do that on a later time. For example, maybe for an integer wasn't defined if it's allowed to go negative or not. Depending on your use cases, that might not warrant the pipeline to stop at that very moment, but you want it to continue and then go ahead and fix it later. This is especially true if you start with that with already existing APIs, because if you define your rule set, you will have a lot of existing APIs failing. So I guarantee you that if you have the situation where you didn't do automated security checks on your APIs until now, and you're adding it and everything is green, then my respect, but usually you have some APIs that will not be green. And in that case, you wouldn't be able to push any changes. But if you do that, if you say, okay, if it's not secure, if the checks find something we want to stop, then this is called a quality gate, right? So you can say, okay, this is okay, this is okay. Okay, if that is no. And then you have a quality gate. You can stop the whole automated process right there to make sure that only changes that make it through the quality gate, you would go to production. There are also different or other names for this. And one implementation, for example, is Microsoft Secure Development Lifecycle. So you can have a look at that if you're more interested in those gates. Now, what did we check? We checked the specification. We checked the definitions of the proxy, but we didn't check the API itself. So having a great spec, having a spec that says, okay, I'm secure, written all over it, doesn't help you a bit if the API that implements that spec doesn't do all the checks that the spec thinks are necessary. So what you can do is you can really run some automated end-to-end tests here. That is also called behavioral analysis or dynamic code analysis. So you can really try, okay, what happens? This field, it's supposed to be a number. So what happens if I enter a string into it? Or what happens if I give a negative number to that parameter? So all of these things you can test with automated tests to make sure that the API actually behaves like the spec says. Now, the question is, what tools do I use, right? So if you now want to start, you start tomorrow, you go, I'm at home tonight, and you think, okay, that would be a great thing. Now, what to do tomorrow? Well, there are quite a lot of good tools out there. So talking about the spec level, that process of checking a spec against a given set of rules is called linting. And I just said these tests, these end-to-end tests or integration tests are dynamic analysis technique, and that one is a static, which basically means you just need the spec for it. You don't need the implementation for it. So this linting is very cheap from the processing cost, right? You can do that fast. You can do that often. You can do that while you are developing, while you are writing that spec, essentially. And one of the most well-known linters out there is Spectral, and our very own product, our API control plane, also has linting capabilities. A bit more on that later. And both of the tools for the scope of linting are free to use. So even our control plane, the linting functionality will be free for use for everyone. So there is no reason not to lint your specs, because there are solutions out there and these solutions are free. So there's no excuse because business doesn't have the money to do so. When it comes to proxy level security, the story is a bit different, because what you now need are basically the proxies as they are created on the API gateway. And the problem here is that that is highly different for each API platform out there. So what you need to do first is like get the configuration from the gateway, get that proxy. That is a different process on all the platforms. These proxies do have different formats. So for example, layer 7 uses an XML-based export, Gravity uses JSON. So there is no, unique or unified way to check that. So luckily we got you covered there. Our API control plane is able to extract those proxies from a wide array of API gateways. The starting set I will show you in a minute on what we currently support. And we are basically adding new platforms going forward because that is really our expertise. As you know, Apida is the API management company. We work with a lot of great API gateway manufacturers. We are one of the, for example, we are the #1 European partner for layer 7 gateways. So we do know quite a lot about the internals of these different systems, and we put our knowledge to good work in the control plane. So these checks that I showed you in the security measures, that is actually what we check within the control plane. And as you will see, we give you a nice rating, so it's easy to grasp how good your security is. On the process level, of course, tooling support is kind of limited there, because need to know is something that you can't enforce using a tool. You can try, but you won't succeed. People are sending out connection data via email every day. There are probably a lot of passwords floating around in Slack and in Teams channels. If I recall correctly, I think one of the Twitter hacks actually was someone getting access to Twitter's Slack channel and getting a password from there. So of course you can't use much tooling there, but what you can do is you can decouple your infrastructure from the pipelines. Now imagine your pipelines are going to publish these APIs into testing environments. So you can pick them up there, do some manual Q&A, do some automated test runs there. And maybe the pipelines also deploy directly into production, which basically means that the pipeline needs to connect to your production environment. In order to do so, it needs to know what are the host names, how do the credentials look. Again, make sure if you do it like that, that you have the secrets in the vault of the CI/CD pipeline and don't have passwords, administrative passwords in your pipelines that connect to your production system. But one of the problems that remains is what actually is your production system. Now, if you have multiple APIs and you have the connection information to your production service within that pipeline, that means that if something in your production environment changes, you change the host name, you move into the cloud, or basically you have multiple deployments and you want to shift APIs from one environment to the other. Maybe you're currently right now moving from your on-prem data centers to the cloud, then you have to change all of your pipelines. And if you forget one, then your process breaks down. So what you want to do is you want to decouple it. And what we support there within our product, the API Gateway Manager and the API Control Plane, is exactly that decoupling. Because what you then do in your pipelines is just you say, okay, deploy to my integration environment. And that's all that you say. And our systems, they know what the integration environment actually is. They know how to connect to it. They know how to make sure your API is published there. And that means if you change something in your environment, you just have one place to change it. You change it within our product, and all of your pipelines reflect that change immediately. You don't have to do search and replace on all of your APIs, on all of your Git repositories, right? So that is a huge plus there. Abstract it away, get your single point of truth for your API infrastructure, and we can help you with that. So we have been looking at the security measures on the different levels, and we have been looking at how to enforce them within the context of APIOps. But what else is there to consider, right? That can't be all, right? So there must be something else, something you might not, that might not come to mind automatically, where you have to think a bit harder. Well, first of all, let's just look at some best practices for you to have a guide. Again, if you want to improve your API security tomorrow, this is your starting point, right? So again, zero trust and encryption, encrypt all your network traffic. And no matter if that traffic is in your DMZ, out of it, if it's in your company network, be suspicious of every traffic, encrypt it. And of course, make sure you're only accepting new algorithms, not the old broken ones, because your security is just as good as the worst algorithm that you are supporting. Again, authenticate every party that is involved, not only the user, but also the application that tries to connect. For identity providers, especially important if you are an industry where you have to know your customer, don't roll your own solutions. Use one of the existing ones. There are free open source ones out there. Don't try to build your own OAuth or OpenID Connect implementation, because the biggest issue with the security is basically implementation, right? So you make an error there and your security is gone. So just trust on systems that have been used by a lot of people, that have been looked at by a lot of people. Don't run your own. Another best practice is ask for help. So we have a lot of customers that come to us, not when it's too late, but at a very late stage. And it would be far easier and far, a more pleasant experience for the customer itself if you ask for help earlier. So make sure you monitor and audit everything. So you want to know everything that is going on in your system. One reason is troubleshooting. So if someone calls you, I have a problem, you need the insights into their requests to see what the problem is. And of course, security. You want to know when you are attacked or when someone tries or snoops around. Again, we already had that. Share as little as possible. And of course, protect your infrastructure. Use rate limiting, use throttling to keep everything in the working parameters. Of course, you can apply dynamic scaling, but make sure that you don't overload your infrastructure. And again, validate the requests. So if you have a spec, and if you don't have a spec for your API, that's the first thing to do, right? So if you are developing APIs and you don't have a spec, no matter if it's OpenAPI, it's async API, whatever language you would prefer, but if you don't have any spec, you're not doing your job. So an API without a spec is the worst thing there is. Go fix that first. But if you have a spec, make sure all the requests are validated against it. And that means that you offload your upstream systems, because every request that is not valid doesn't even go to the upstream system. Stay up to date. Make sure that your infrastructure is updatable. That is, that you can always apply the newest versions. Have a regular look at the OWASP Top 10, which collects all of the security incidents that are very common in systems. And if you ask us, use an API gateway. Don't try to build security into every of your APIs from scratch. Use a gateway, offload some of the things that I just showed you, like for example, schema validation, you can do that on the API gateway. You don't have to implement it in every service, especially not if it's a microservice. And if you have more than one API gateway, that isn't the problem. I already mentioned our API control plane product, and that product can work with all these different vendors. Again, we're adding more month to month to make sure your APIs are configured correctly on that platform. They are accessible. People can get access to them. So use a gateway, use a dedicated API management platform, use a control plane that is split from the data planes, from the gateways itself. It makes your life so much easier and it brings a ton of value. So I promise you, you won't regret it. Another thing to consider is quality. So right now we have been talking about security, but what is also important is quality, because the security is just a necessity, right? You have to get that right. But quality is where you can really make a difference. So if you are thinking, oh, the adoption of my API is a bit too low, and people are doing a lot of errors with implementing that API, you have to do so much support, then have a look at your quality of the APIs. Because the better the quality, the easier it is to adopt, the less errors you have, and the less errors in implementations that you have, you don't have to, you don't have to support a running system. It's fine, it's running. Which frees more time to do other stuff. And of course, a good developer experience just makes everyone happy, and people recommend your APIs and you get wider adoption. So this is a screenshot from our control plane, as I mentioned earlier. So what we compute for every API is a security score and a quality score. And you can use both of these values, for example, as a quality gate in your CI/CD pipeline. Or you can also use it as a quality gate in publishing, which basically means the API is available, but in your developer portal, in your API catalog, it is, for example, not shown until quality has raised to a significant level. So, for example, you might be technically complete, but documentation is lacking, right? Stuff like that. So make sure that you somehow not only measure security, but also measure quality. Another thing you should be aware of is you should know your attack surface. So we have talked about how to secure an API, but to secure an API, at the first place, you need to know that it is even there. So make sure that you have an API catalog that actually has all your APIs in it. So the problem with the developer portals and API catalogs that the most API gateways supply is that it is limited to this very gateway. So for example, if you are running a Broadcom layer 7 infrastructure, the developer portal is limited to the layer 7 gateways. Now, if you also have something running on Amazon, like some AWS Lambdas that you expose, or if your internal APIs run on some open source gateway, that means your API catalog is incomplete. Not every API is listed there, so you can't secure every API. So make sure you have an API catalog that is connected to all your gateways and ideally makes automatic discovery. So that also if someone puts something on that gateway using not your shiny new APIOps processes, but the vendor supplied management portals and applications, make sure that you catch these as well, because otherwise you just keep finding APIs where you don't know who built them, who is responsible, how have they been built, are they even used, and you don't want to have that, so use such an API catalog. Now, the first step in order to improve is know where you are now. So how do you stack up? How mature is your API management system within your organization? And we have developed a simple API management maturity assessment, just a simple set of questions that you answer. And we report on how good you are doing with these different categories and what you can improve to make sure that you really get the return on your API program that you are hoping for. We're currently in the final stages. We are finalizing it right now, and we are sanity checking with all different people in the marketplace to make sure it's not just our understanding, but it's the understanding of the industry as a whole. And if you want to be notified when that tool is available, make sure that you go to our website, subscribe to our newsletter, or you can also follow us on LinkedIn, and then we will notify you the moment this tool is available. And that's with today's topic, with security. What's coming up? Well, we have the last entry to the series scheduled for September 27th right now, where we basically do, just a consolidation or a recap of all the prior webinars, which is called APIOps from start to finish. So make sure, if you just want a crisp summary of what is APIOps, how it will improve your API management, and how to get started with it, then make sure to tune in on September 27th. And with that, I thank you for your attendance today. And if you have some questions you would like me to answer immediately, just put them in the chat. We will try to do it right now. If you have some questions later on, don't hesitate to contact us. You can contact me directly using LinkedIn, using email, or any one of my colleagues as well. We always love to chat about API management, and especially API security. So don't hesitate and reach out. Okay, so we got one question coming in, which basically is how to get started when you already have an API management platform running, but are not using APIOps yet. So what I suggest in that case is that if you right now don't have APIOps running, what you usually have is you have some kind of API team or platform team that takes care of all the operations, that takes care of publishing. Introduce APIOps in that team first without opening up. Don't go directly for you build it, you run it. Build all the processes, build all the automations within that team. Also add the security stuff in there as well, right from the beginning. That's the easiest thing. The earlier, the better. Of course, you cannot have quality gates, or they can't be too restrictive, because otherwise you can't push any changes anymore. But just make sure that you watch these numbers, right? As I said, the control plane gives you that quality score and that security score, and also how it evolved over time for that API. So just make sure that the numbers go up. And if you are ready, add the quality gate, and then you are ready to open up to the upstream teams, right? So that is what I would recommend there. So any more questions? Okay, doesn't look like it. So thanks for your attendance again, and have a good day. Bye.